Good morning, students. Today we will discuss some problems based on the chapter Curves in Space. So the first problem is find the arc length as a function of theta along the epicycloid whose equation is given by x is equal to a plus b into cos theta minus b cos of a plus b into theta divided by b. Y is a plus b into sin theta minus b sin a plus b into theta divided by b, and z is 0. So these three are the coordinates of the point on the epicycloid, and we have to find the arc length as a function of theta. Now to find the arc length, we require all the derivatives of x, y and z. So let us find the derivatives of x, y, z with respect to theta. So firstly let us differentiate x with respect to the parameter theta. Now here a plus b is constant. The derivative of cos theta, that is minus sin theta, and here b constant. The derivative of cos, that is minus sin, and the derivative of this argument, that will be a plus b by b, because the derivative of theta, that will be 1. So from here we get the value of dx by d theta, which is minus a plus b into sin theta plus a plus b into sine of a plus b into theta divided by b. Now let us find the derivative of y. The derivative of y with respect to theta, that is dy by d theta. On the right side, a plus b is constant. Derivative of sin theta is cos theta minus b as it is. Derivative of sine, that is cos of a plus b into theta by b, into the derivative of a plus b into theta by b is a plus b by b. Now this b is cancelled with this b, so we get the value of dy by d theta. Now z is 0, so dz by d theta, that will be 0. Now let us find the magnitude of r dot. Here r dot means the derivative of vector r with respect to perimeter theta. Now by definition of magnitude, it is given by the square root of the sum of the squares of dx by d theta, dy by d theta and dz by d theta. Now substituting the values of dx by d theta, dy by d theta and dz by d theta here and simplifying. Now a plus b whole square is common from the expressions, and inside we are left with 2 minus 2 into cos of a theta by b square root. This is the magnitude of the vector r dot. Now after simplifying this expression further, we finally get the value of the magnitude of the vector r dot, which is 2 into a plus b into sine a theta divided by 2b. Now by definition, arc length s is given by integral from 0 to theta of the magnitude of the vector r dot. Substituting the value of r dot here and integrating with respect to theta. Now this term is constant. Derivative of sine, that is cos, so we get cos a theta by 2b, and in the denominator we have divided by the coefficient of theta, which is a upon 2b. So after substituting the limits here, at 0 cos 0, that will become 1, and here if we put theta, that will remain as it is. So we get finally the arc length for the epicycloid, which is given by 4 into a plus b into b upon a into 1 minus cos of a theta upon 2b. Now the next problem is show that the curve for which e raised to the power ax is equal to b minus t upon c minus t, e raised to the power by is c minus t upon a minus t, and e raised to the power cz is a minus t upon b minus t. We have to show that the curve for which these expressions are given is a plane curve which lies in the plane ax plus by plus cz is equal to 0. Now in order to prove this, as we know, because oscillating plane of a curve, that is the plane containing that curve. It means we are to find the equation of oscillating plane for the given curve. Now to find the equation of oscillating plane, we require all the first and second order derivatives of x, y and z. So let us first find the values of x, y and z from the given expressions. Now because we are given e raised to the power ax is equal to b minus t upon c minus t. So let us take log on both sides. Here if we take log e, that will be 1, so we get ax. Here we take log of m upon n, that is log of numerator minus log of denominator, so we get log of b minus t minus log of c minus t. Now to find its derivative, let us differentiate both sides with respect to t. So from here a into dx by dt, here the derivative of log, that is 1 upon function, into the derivative of b minus t, that will be minus 1. Again here log of the function, its derivative will be 1 upon c minus t. Then derivative of c minus t, that will be minus 1, so we get plus sign here. Now taking LCM of these two terms, we get a into dx by dt is equal to b minus c upon b minus t into c minus t. Now from here, let us find the value of dx by dt, which is given by b minus c upon a into 1 upon b minus t into c minus t. Now to find the second order derivative, let us again differentiate with respect to t. Now here the second order derivative of x, that is given by d2x by dt2. This term is constant. Here we can use product rule. First function 1 upon b minus t as it is, derivative of 1 upon c minus t, that is minus 1 upon c minus t whole square, and the derivative of c minus t, that will be minus 1, and plus second function as it is, the derivative of 1 upon b minus t, that will be minus 1 upon b minus t whole square, and the derivative of b minus t, that will be minus 1. So we get this quantity. Now taking the LCM inside the brackets, we get b minus t whole square into c minus t whole square as LCM, and the numerator we have obtained b plus c minus 2t. So we have obtained the value of d2x by dt2. Now in the same way, we can find the value of derivatives for y and z. To find the derivatives of y, from here let us take log on both sides. On the left side we get by. Here taking log, this will become log of numerator minus log of denominator. Now differentiating both sides with respect to t. Here b is constant, the derivative of y is dy by dt. Here the derivative of log, that will be 1 upon function 1 upon c minus t. Then the derivative of c minus t is minus 1. Here again derivative of this term is 1 upon a minus t. Then the derivative of a minus t, that is minus 1, and this minus, so we get plus here. Now again taking LCM, we get the value of this term, which is c minus a upon c minus t into a minus t. And taking b on the right hand side, we get the value of dy by dt, which is c minus a upon b into c minus t into a minus t. Now again differentiating this term, we get d2y by dt2 is equal to c minus a upon b is constant. Here we can use product rule. First function is 1 upon c minus t, that will remain as it is. The derivative of this term is minus 1 upon a minus t whole square. Then derivative of a minus t will be minus 1, plus second term as it is, derivative of 1 upon c minus t, that will be minus 1 upon c minus t whole square into minus 1. Now again taking LCM, we get the value of d2y by dt2. In the same way, you can find the value of dz by dt and d2z by dt2. Now we are to find the equation of oscillating plane. So by definition, the equation of oscillating plane is given by the determinant equated to 0. In the first row we have x minus x, y minus y, z minus z. In the second row we have x dot, y dot, z dot. In the third row we have x double dot, y double dot, z double dot. Now substituting the value of x, y, z and all these first and second order derivatives, we get the equation given by this. Now in this equation, in order to make it convenient to solve, let us take the notations for these terms which are in the second row and the third row. We have denoted this term by A, this term by B, this term by C, this by D, E, F. So after taking the notations, we have this equation which is given by x minus 1 upon A into log of B minus T upon C minus T, y minus 1 by B log of C minus T upon A minus T, z minus 1 upon C log of A minus T upon B minus T. In the second row we have ABC, in the third row we have D, E, F, and this is equal to 0. Now expanding this determinant by the first row, we get this kind of equation. Now in order to further simplify it, let us find DF minus EC, AF minus DC and AE minus BD individually. So first of all, let us find the value of BF minus EC. Now substituting the values of the symbols B, F, C, E here, and from these two terms we can take this quantity common. Inside we are left with these two terms. After taking LCM here, we get the value of BF minus EC, which is given by this formula. Now A minus T is cancelled from numerator and denominator, and we get this value. In the same way, you can find the value of AF minus DC and AE minus BD. Now you will substitute all these values from the equations 4, 5 and 6 in the equation 3. After substituting the values there, you will get the equation of oscillating plane, which is obtained as x minus 1 upon A into log of B minus T upon C minus T into minus 1 by BC minus y minus 1 by B into log of C minus T upon A minus T into 1 by CA plus z minus 1 upon C into log of A minus T upon B minus T into minus 1 by AB is equal to 0. Dividing throughout by A minus B into B minus C into C minus A divided by A minus T whole square, B minus T whole square, C minus T whole square, you will get this expression, and you can see all the other terms will be cancelled out and you will only be left with AX plus BY plus CZ is equal to 0. Now replacing capital XYZ by small xyz, we get the equation AX plus BY plus CZ is equal to 0, which is the required equation. So these were some problems based on the chapter curves in space.